Okay, grade 8s, now we're going to be dealing with patterns that do not involve a constant ratio or a constant difference. Remember, we did the first one where there was a common difference, that difference was D, and we created a general formula for it. Then we had a constant ratio, and that ratio was R, and we created the formula for it. Now, these are not going to have a constant difference or constant ratio. It doesn't mean we can't create a general formula, but we're not going to do that now. We're just going to practice working with these patterns because they are still patterns. Right, so sometimes they don't have a constant difference or constant ratio, but it's still a pattern, like I just said. Sometimes there's an uncommon first difference. What do I mean by that? Let's look at an example. I have 1, 4, 9, 16, 25, right? Term 1, Term 2, Term 3, Term 4, Term 5. This is n is 1, n is 2, n is 3, n is 4, n is 5. And I look at my first difference like we did in the previous videos. So our difference of Term 2 minus Term 1, and that is 3. So 4 minus 1 is 3. Remember that was Term 2 minus Term 1. That's our difference. And we call that D1, and that is 3. But now we look at Term 3 minus Term 2, and we see that that is equal to 5, because that is 9 minus 4, and that is 5. And you can see that the difference is not constant, but you can see that there's a constant difference probably between the second or the first difference. So we call this difference 2, because we go 5 minus 3, and that is 2, 7 minus 5 is 2, 9 minus 7 is 2. So this, for example, we call a constant second difference. It has a pattern. We're going to call that pattern 1 squared plus 2 squared, or 1 squared, 2 squared, 3 squared, 4 squared. Because you can see this maybe reminds you of your square roots and squares. Let's look at another example. We have T1 is 2, T2 is 4, T3 is 12, T4 is 48, and T5 is 240. Now sometimes there's an uncommon ratio, right? Remember N1 to N5? Now the ratio is T2 over T1, and that is equal to 4 over 2, and that is 2. Then we look at the next ratio, which is T3 over T2, and that is equal to 12 over 4, and that is equal to 3. Oh, so our ratios are not constant. It looks like every time we add a difference of plus 1 to our ratio. So this is an example of an uncommon ratio. So let's look at this formula. 2n squared minus n plus 5. And I ask you, what is the fourth term? So you're still able to do this, even if we don't know the general formula. A4 is equal to 2. Remember, we've made n is equal to 4. We put 4 there. 4, 4. What is 4 squared? 16. So we have 2, 16, minus 4 plus 5 is 1. 2 times 16 is 32, plus 1 is 33. What about given the formula t n cubed minus n squared? We have now got to solve the third term. So we say t3 is equal to 3 squared. Remember, we swapped our n for 3 minus 3 cubed minus 3 squared. What is 3 cubed? You should know this. That's 27. 3 squared is 9. 27 minus 9 is 18. And that is our third term. Okay, we look at this formula. Now, this might look completely confusing, but you'll be able to do this. Tn is equal to 5, 2 minus n plus n over n. Oh, a like term over a like term, that's going to go to 1 straight away. That's easy. Let's go. What is term 3? Now, term 3 is sometimes referred to as A3. So T could be the same as A, the number 3, just the same thing. What is 5? 2 minus 3 minus 3 to the power of 3 plus 1. So, what is 5 to the power of negative 1 minus 3 to the power of 3? What is that? 27 plus 1. Right, that was easy. That went to our 1. So 5 to the power of negative 1 is the same as 1 over 5 to the 1. And 5 to the 1 is 5, so that's 1 over 5. Negative 27 plus 1 is negative 26. What is the same as 1 over 5? That's 0.2. 1/5 of 1 is 0.2. 0.2 minus 26 is negative 25.8. Okay, so that might seem a bit complicated, but you can do that, grade 8s. Let us continue. Given the formula Tn equals n squared plus 4, what is the sum of the first three terms starting at n is equal to 1? Okay, let us calculate that. T1 is equal to n1, 1 squared plus 4. What is 1 squared? Oh, easy. 1 squared is 1 plus 4, and that is equal to 5. What is T2? T2 is 2 squared plus 4. What is 2 squared? That's 4 plus 4. That is equal to 8. Nice. T3, 3 squared plus 4. That is equal to 9 plus 4, which is equal to 13. We're given the formula Tn is equal to 2n plus n. What is the third and the fourth term starting at n is equal to 1? Okay, so T3. Oh, what is the sum of the third and the fourth term? Okay, T3 is equal to 2 to the power of 3 plus 3. What is 2 to the power of 3? 2 squared is 4, times 2 again is 8. That's 8 plus 3, and that is equal to 11. What is T4 is equal to 2 to the 4 plus 4. So 8 times 2 is 16, plus 4 is equal to 20. What is the sum of these formulas? The sum, or the sum of these two terms, is equal to the sum of T3 plus T4 is equal to 11 plus 20, which you can see simply equals 31. Well done, grade 8. Those are patterns not involving a common difference. It's really just a summary of some of the skills you learned in the last two videos. We're going to now move on to functions and relationships. Well done.